So the first thing we're going to do is take a look at how to graph some of these exponentials. So we know they're either growth or decay, and this one's a 4, so we know it's a growth, and we know it's moved up 1. So the first thing we are going to do is dash in a line at 1 here. And then the next thing we can do is we can make an XY table and label some points. So let's see, when x is 0, 4 to the 0 plus 1, so 1 plus 1 is 2. When x is 1, 4 to the first is 4 plus 1 is 5. So we know it's 0, 2, 1, 1, 2, 3, 4, 5. And we know it's exponential growth. So we have our curve here. So this next one I look at and I see 1/3, so I'm thinking decay. And it hasn't moved up or down at all. So that dashed line, that asymptote is right at the x-axis. And let's see, we can make a table again. 0, so 2 times 1/3 to the 0. Well, anything to the 0 is 1. 1 times 2 is 2. And then 1. So 2 times 1/3 to the first. 2 times 1/3 is 2/3. And we can see we have that decay there. Now this next one, first thing I notice is that's plus 1. So our asymptote's moved up 1. And I notice that this is a growth, but we have this reflection here. So let's see, it's a growth, but it has to have reflected, so it's going to look like that. Then let's see, if we make that XY table 0, well, -4 to the 0 plus 1. Well, 4 to the 0 is 1, so -1 plus 1 is 0. So we have a coordinate at 0, 0. And -4 to the first plus 1, well, 4 to the first is 4, so -4 plus 1 is -3. So 1, 1, 2, 3. And we can see that it's that growth curve, but it has been reflected. Oh, and it looks like I didn't forget that there were some here. So our y-intercept, 0, 2. Our asymptote was at y equals 1. In the range, y has to be greater than 1. Our y-intercept was at 0, 2. Our asymptote was at 0. In the range, it was all greater than 0. Our asymptote was at 0, 0. Or excuse me, y-intercept, y equals 1. And then our range, y was less than 0. So again, on this next page, I see that this is a decay, but what happened to this decay? Well, it moved down 2. So it's at y equals -2. We make that xy table, so 0. So we have 1/3 to the 0 power minus 2. So 1 minus 2 is -1. Then we plug in a 1, 1/3 to the first minus 2. So -1 and 2/3. And we have our decay model. So our intercept was 0, -1, and y was greater than -2. Now this next one, 2, I see that it's a growth, but it has a reflection as well. So we know it's a growth, but it's been reflected. So if we make an xy table, x, -2 to the 0, well again this is 1, but it's got to be -1. When we plug in a 1, -2 to the first, well that would be -2. And again that asymptote would be at 0 in this case. So we have y equals 0, 0, -1, and it's been reflected. So y has to be less than 0. Now the next one here, we have our growth, but you'll notice the negative is up there, so it's the opposite x. So we know that it's a growth, but we know that it's been reflected over the y-axis because it says our x values are the opposite. So here it'll flip and look like that. But plus 3, so we know that it's moved up 3. So y equals 3. And that xy table on this one. Well, let's see here. 0, 2 to the negative 0 plus 3. Well, that's just 1 plus 3, so we have 4. And then 2 to the first plus 3. Well, that'd be negative 1, excuse me, because it's the opposite of x. So we know that this is 1 over 2 to the first plus 3, so we have 3.5. And we can see, yeah, it's that growth, but it's been reflected. So it looks like a decay because of that reflection there. Now when we look down at the bottom here, we have to write some equations. So if you guys remember, it's our initial amount, 1 plus our rate to the time. So our initial amount is 4, 1 plus 15%, and we want to go for 6 hours, or you could write 4 times 1.15 to the 6. On this next one, our car depreciates in value over a time. So it was purchased for $12,329. It decreases, so minus 0.85 to the t power. On this next page here, we're going to take a look at evaluating some of these. So the fifth root of 32 cubed. So we're thinking some number to the fifth gives you 32. So that's 2 cubed, which is 8. So the cubed root of 27, what cubed gives you 27? Well, that would be 3 squared, which is 9. We can take a look at this next one here, the square root of 25. Well, you guys know that that's 5. So 5 cubed is 125. And then we need to split these apart. So 64, our denominator, squared. So what number, again, cubed, that's the cubed root, gives you 64. So we have 4 squared, which is 16. And let's see, 4 to the 1/2 to the 5th power. So what number squared gives you 4? So that is 2 to the 5th, which is 32. Now these next ones here we have to distribute. And it helps to write it out. So we have x squared times x cubed plus x squared times 2x squared plus x squared times 1. So x squared times x cubed, we add our exponents, so x to the 5th, plus 2x, 2 and 2 is 4, plus x squared. And here it's the same thing, even though we have some fractions here. We have to distribute x to the 1/2 times x to the 3/2, x to the 1/2 times 2x to the 1/2, plus x to the 1/2 times 3x to the negative 1/2. So again, we add 1/2 plus 3/2, well that's 2, plus 2x, 1/2 plus 1/2 is 1, plus 3x, 1/2 and negative 1/2 is 0, and well, we know anything to the 0 power is 1, so we have x squared, 2x to the first, plus 3, because 3 times 1 is 3. Well, now we need to evaluate some of these. So we have to take the square root of everything. So some of you might think, well, let's rewrite it with exponents. 8 to the 6th, b to the 9th to the 1/2. And if we distribute, we have 25 to the 1/2, x to the 6/2, b to the 9/2. Well, 25 to the 1/2, the square root, so that's 5x cubed, b to the 9/2. This next one here, well, that's to the 1/3 power. So we distribute, so 64 to the 1/3, x to the 2/3, y to the 7/3. And we're thinking what number cubed gives you 64? So we have 4x to the 2/3, y to the 7/3. So why don't you try these next two and then check them on the answer key. Now when we look to the distributing here, these at times can get a bit confusing. Make sure you're writing out your steps here. So if you want to distribute that 3 first, it becomes 2 to the third, x to the negative 9, y to the 6th, x to the negative 6th, y to the 6th, over x to the third, y to the negative 9th. We could distribute our negatives. Well, I know 2 cubed is 8. Not distribute, I mean we have to flip our negatives. So x to the 9th flips, y to the 6th stays, x to the negative 6 flips, y to the 6 stays, x to the third stays, y to the 9th flips. So now we have 8y to the 21st over 15x to the 18th. So this next one here, if we distribute that 2 first, negative 2, 2 to the negative 2, a to the negative 4, b to the 4th, 3 to the negative 2, b to the 4th, over, well, the bottom, there aren't anything, so we could combine here. We have 2a to the 4th, b cubed. And let's see, so we have to, let's see, flip 2 squared would go on the bottom. A to the 4th, b to the 4th stays. 3 squared. Let's see, b to the 4th stays. And everything on the bottom stays. 2a to the 4th, b cubed. Let's see, so we have a total of b to the 8th on the top. Our number, we have 4 times 9 times 2, so 4 times 9 is 36 times 2 is 72. Is that a to the 8th, b to the 3rd? Well, our b's would simplify to b to the 5th on top, 72a to the 8th. Ooh, these are some long ones. Looking at this next one, this one's a little bit easier. 3 to the negative 2, x to the 4th, y to the negative 8, and we flip x to the 4th, 3 to the positive 2, y to the 8th, and we know 3 squared is 9, so x to the 4th, 9y to the 8th. I'm going to stop it here, and then you can start with the second half on number 23.